Hello and welcome to the eOrganic webinar on maximizing dry organic dairy pastures. This webinar is part of an ongoing series we are holding focused on the Access to Pasture rule released this summer by the USDA National Organic Program. My name is Deb Haliba and I work at the University of Vermont Extension as eOrganic's Dairy Team Coordinator. eOrganic is an online community of more than 500 ag service providers and farmers who are providing science, experience, and regulation-based certified organic information on the web. Together we publish articles, videos, and other content at eextension.org. You can see more information about our webinar series, find the recording of today's and previous sessions, and view our other content on our website at www.extension.org/organic_production. Before we get started, I wanted to give a quick rundown of today's webinar. Karen will give her presentation for about 45 minutes. Then we will ask you to respond to a few quick poll questions that will appear on your screen. Next, we will hold a question and answer session with Karen for about 30 minutes. So if at any time you have a question, you can simply type it into the question box on your screen and hit return. If you can't see the question box, you can click the small plus sign next to the word question on your control panel to open it up. And during the question and answer session, we will answer as many questions as we have time for. And finally, we ask that you respond to an email you will receive following this session to complete an online survey about today's webinar. Okay, now I would like to introduce our speaker for today. Karen Hoffman is an animal scientist with the USDA Natural Resources Conservation Service in New York, and she is also the New York State Coordinator for the Grazing Lands Conservation Initiative. Karen received her Bachelor of Science degree from the Animal Science Department at Cornell University and her Master of Science degree from the Department of Dairy and Animal Science at Penn State, where she studied grain feeding strategies to high-producing dairy cows on rotational grazing system. Karen has worked with dairy and other livestock producers on their grazing systems for more than 15 years as a dairy management educator at Cornell Cooperative Extension and now as an animal scientist specializing in grazing nutrition for the USDA Natural Resources Conservation Service. Karen, welcome and thank you very much for joining us today.
Thank you, Deb. I'm still learning how to use this webinar stuff, so I'm going to apologize to people in advance if I'm a little slow on things here. But first of all, I'd like to say good afternoon to everybody, and I'd also like to thank Deb and the other folks at eOrganic for inviting me to do this webinar. As Deb mentioned, my presentation today is going to be on maximizing dry matter intake from organic dairy pastures. And I'm also going to talk a little bit about some nutritional concepts in addition to the grazing management stuff. So with that, I guess I will get started with my first official slide here. So when we talk about maximizing intake from pasture, of course, we're all tuned into this webinar today because, as Deb mentioned, the National Organic Program did come out with their pasture rule, which states that 30% of grazing livestock, 30% of a grazing livestock animal dry matter intake has to come from pasture, and that is over the course of 120 days per year. And so obviously we're all interested in learning how to meet that new requirement. From my perspective as a nutritionist, I really believe that pasture is one of the cheapest feeds that you can provide to your animals, and it helps to keep your organic costs low. And that's really something that I've been working over the last few years with some organic producers on trying to make sure that those costs stay relatively low. The nice thing about pasture is that it is highly digestible, which means that our cows can eat a lot more pasture as a percentage of their total intake than they can of other types of forages that would have less digestibility. And because it's highly digestible, obviously they have that higher intake, and anytime you can get your cows to have a little bit higher intake, they will actually produce a little bit more milk. Every extra pound of dry matter intake equates to about 2 pounds of extra milk in the bulk tank. And I really view Pasture as sort of, it's almost like doubling or tripling your money if you can get an extra pound of dry matter from this very low-cost feed. Now, when I think of Pasture, I think of Pasture that's 6 to 8 inches tall, just like this one here in the photo, with the leaves growing straight up. They haven't grown up taller than that and then flopped over and made a pile that's 6 to 8 inches tall. And when it's that tall, the really nice thing about it is that when we turn our cows into those kinds of pastures, they will put their heads down and immediately start grazing, unless, of course, they're trying to check the fences, which we know that they do. And as you can see here in this photograph, there was a temporary fence right here that this farmer pulled out of the pasture, and these cows are all very eagerly going at grazing in that new section of the pasture. They have their heads down, and the chances are very good that their heads will stay down for a very long time as they continue to graze. Now, in my next slide, we have some examples of some pastures that probably you would have a very difficult time maximizing intake from. This pasture up here, there's just not enough quantity, although the quality is probably extremely high because it is very short. This pasture, there just isn't enough of it, lots of mud and puddles and so on and so forth. This pasture here, this cow that's standing here in the shrubs probably should be on this side of the fence and consuming that nice lush green forage instead of being stuck into a brush lot where they're probably not going to find an awful lot to eat. And then this kind of a pasture, for those of you who aren't aware, milk does not come from milkweed. It comes from cows eating high-quality grass and clover combinations. So if you have a very weedy pasture, it's also very difficult for them to meet their dry matter intake requirements. So when I think of grazing and meeting that pasture requirement, I'm really thinking of people using a rotational stocking method. And what we do when we use a rotational stocking method is in the early spring and early summer, we have our system set up so that we graze half on this side of the system. And then on this side, we take that first for hay or silage. So it's a graze half, harvest half kind of a situation. In the early spring, the grass will regrow on about a 15-day rest period. So if they start down here and they graze through for 15 days, they can come back down to this first paddock, and it should be 6 to 8 inches tall again. Of course, that depends on whether or not there's enough moisture and the temperatures are at the right level for grass to grow well. In the midsummer and into the fall, we need a longer rest period because of high temperatures, lack of moisture, and so we need a 30-day rest period to get all of our pastures back to that 6 to 8 inch height. So we would add in where we took the first cutting off to get to our rotational stocking method during those times of the year. In terms of dry matter intake, there are 3 main factors that are going to influence dry matter intake, and anything that interferes with that process is going to reduce their intake and their animal performance. So the major things that influence dry matter intake are the biting rate, the bite size, or the amount of feed that they take in per bite, and the amount of time that they spend grazing. And they're all interrelated, and there's lots of things that influence each one of those factors. So we're just going to go through some of those at this point. Biting rate per minute is the one that I think most people don't consider when they're looking at their pastures. Cows can graze between 50 and 70 bites per minute, which means that they have their head down and they're basically biting and swallowing, biting and swallowing, biting and swallowing. very, very rapidly. In a research project that was done here in New York, where cows were being measured for their bites per minute, we actually found that there was a cow that had 93 bites per minute. So she was definitely working at trying to maximize her dry matter intake from pasture at that kind of a biting rate. On average, a cow will take between 28,000 and 35,000 bites per day. So they do have to spend a fair amount of time going through the pasture and having as high a biting rate as they possibly can. The next factor is, actually I'm going to back up here just a second. So when you think about the biting rate per minute and you think about how fast they have to be doing that, one of the things to take into consideration again is that you want them to bite and swallow and bite and swallow and bite and swallow. If they have to walk around the pasture looking for something to eat that's of the right quality, that's going to slow down their biting rate. If they have to search through thorn apples or other kinds of shrubs to find an area that has enough grass, that's going to slow down their biting rate. So really, we're talking about letting them get in there, as I had in that photograph, put their heads down and just go to work. So the next factor, moving on here, is the amount of feed taken in per bite. The amount that they can wrap their tongue around and pull into their mouth is generally about 0.02 of an ounce per bite or less. And considering that they have to eat between 2 and 4% of their body weight per day in dry matter, you can see why they have to have a relatively high biting rate and why we would also want to maximize the amount of feed that they take in with each of those bites. So to increase that amount per bite, one of the things to consider is that the amount that they can get into their mouth with one sweep of their tongue is a function of both the height of the plant as well as the density of your pastures. And if we take a look at a pasture, which is this one here, and we put in a grazing stick, which there's a great video and a previous webinar that talked about how to use a grazing stick to estimate dry matter intake that's on the eOrganic. But if we use our pasture stick and we see that our pasture is 8 inches tall, we might think, you know, this is a great pasture because it's the perfect height. Unfortunately, if you were to lay that stick down in the grass and look down on it, there isn't a lot of density there. You can see we have a grid here, which is what we use to estimate the density of our pastures. And you can see most of the dots that are in the grid in this photograph because there's a lot of dead material. There isn't a lot of nice, thick, dense clumps of orchardgrass or of perennial ryegrass or clover that's covering over that stick. Now, alternatively, in a different pasture, and I'll wait for the slides to catch up. Here's a pasture that's 6 inches tall, and you can see there's a lot of clover, there's some grass, there's some dandelions, there's all kinds of nice green, lush material that the cows can come in there and wrap their tongues around. And when you lay the stick down in the grass, here it is right here. You can't really see that grid that we saw in the previous slide. And so in this situation, we would consider it to be almost the maximum density that you could have in a pasture. So what difference does the density make in the amount of pasture that's available out there? It's pretty significant in that taller but thinner sward, we only have about 900 pounds of dry matter per acre. But down here in the shorter but denser pasture, we have about 700 pounds of dry matter per acre more. So again, going back to that cow putting her head down into the pasture and just biting and swallowing and biting and swallowing, she can grab a lot more material with her tongue in this pasture than she can in this kind of a pasture. There's an awful lot of airspace, and there's a lot of dead material there, and she's just not going to be able to maximize her intake per bite. Now the third factor that, oops, I only clicked once. The third factor that goes into maximizing their dry matter intake from pasture is the amount of time that they spend grazing. On average, they will graze about 8 hours a day. Obviously, if they're out both morning and night, that's split into 2 different periods. They will get up and graze. They will lay down and chew their cud. And then after they're done chewing their cud, they'll get up and have smaller bouts of grazing. The range for time spent grazing can be between 5 and 13 hours a day. And again, if you think about the factors that might influence the amount of time they spend grazing, they may only be grazing for 5 because perhaps they've been fed a lot in the barn and so they're not as hungry. Or it could be because they were able to maximize their intake in a very short period of time and have spent more time laying down chewing their cud, which is really what we want them to do. The more time they spend laying down, the more time they spend chewing their cud, the higher our milk production is going to be. If they're grazing for 13 hours, it could be because there aren't a lot of supplements being fed in the barn, but they need to spend more time maximizing their intake because the pasture is too sparse, so they're spending a lot of time walking around. It could be simply that they are being fed so little in the barn that even though there's enough in the pasture for them to maximize their intake per bite, they just simply need to spend more time grazing in order to meet their total intake requirements for that day. So a lot of those kinds of things you kind of have to think through. How much time are my cows spending grazing and why? What are the things that are influencing that amount of time? Now, a grazing animal does divide their day up pretty much like this. They'll graze for 8 hours, then they'll ruminate for about 8 hours, and then they rest for 8 hours. Their peak grazing times are going to be early in the morning and later in the evening during those gray light hours. Their natural inclination is, as a ruminant, to tank up on feed and then to go and hide, very similar to our white-tailed deer or our other ruminants that are out in the wild and are affected by the whole predator-prey relationship. So you do tend to see more active times of grazing during these gray light hours. It's not to say that they won't get up and graze at midnight if they're hungry or at noon if they're hungry. They may have other times during the day that they will get up to graze a little bit more to help to maximize that dry matter intake. And so this isn't a hard and fast grazing activity period. It's just sort of a guideline so that you can, again, think through things like, okay, are my cows in the barn at 6 a.m. because I'm milking them? Am I leaving them in the barn too late in the morning, trying to get everything done before I turn them back out to pasture? Those kinds of considerations need to be taken into account. Now, in terms of estimating their level of intake, this is probably one of the most challenging aspects of feeding cows on pasture because it is very, very difficult to measure directly. It's not like when your cows are in the barn and you know how many bales of dry hay or how many scoops of grain and how much each scoop weighs, or when you're using a total mixed ration and you've got a mixer wagon with scales to tell you exactly how much you're mixing and feeding and all of those kinds of things. And a lot of it is because it depends on those plant and animal factors, the plant density, how mature it is, which is something I'm going to talk about in a little while, the species of grass that you have available in your pastures. Then there's the animal factors of the biting rate, grazing time, and intake per bite, and the substitution effect of supplemental feeds in the barn. And okay. So when we look at the methods that we can use to estimate intake,
Hello, we're experiencing some technical difficulties. We seem to have lost you, Karen. Are you back? Karen, if you could unmute yourself. Okay.
I'm not muted.
Okay.
Okay. Can everybody hear me?
Yeah, we can hear you now.
Okay.
Could you just go over that slide, though? Because
This one that I'm on now?
Yeah.
Okay. What I was saying is that the methods of estimating intake that we can use really are just estimates. And if anybody has attended any other meetings or webinars related to the new pasture rule, that is the way that they're saying to calculate your pasture intake is to estimate what their intake is, because it is so difficult to get a hold of. But if you can take a pre-grazing availability measurement of how much is in your pasture, you can then also go out after they're done grazing and get an estimate of how much is left behind, and by subtraction you can come up with an availability estimate. The way that I prefer to do it is to look at the predicted dry matter intake requirements for the breed of animal that you have, their milk production, their body weight, all of those kinds of things. Generally speaking, the animals will meet or exceed those dry matter intake requirements if you're managing your pastures as well as we all hope everybody is managing their pastures. It does depend on the amount available out there in the pasture. And so one of the things that I really talk to people about, and I've been trying to get a lot of other nutritionists to do, is to go out there and get a pre-grazing forage availability estimate to make sure that if the ration is balanced for a certain level of pasture, that it's actually available to the cows on a regular and consistent basis. Now, if we look at our research data, we'll find that about 2.2% of their body weight is a typical intake level when they're being fed grain, and that will result in about a 60 to 70% forage diet. Another way to look at it is based on the forage NDF intake, and I'll go over some calculations here later on how to do that, up to about 1.4% of their body weight from NDF. Now, if you're going to be doing pasture only and not supplementing with any grain, you can get up to about 3.25% of their body weight, but there is going to be a limit on milk production because of a lack of energy, and I will be talking about that in a little bit as well. Oh, I forgot about that little graphic. So basically what this is saying is your predicted dry matter intake requirements need to be double-checked against your pre-grazing availability. Okay. So we have higher quality feed as compared to our stored feeds when we're talking about well-managed pasture. And of course, this is only when the plants are in the vegetative stage of growth. As a nutritionist, I really think about the rumen bugs perspective on what's happening in the rumen to optimize their ability to function. And when I say rumen bugs, I mean the bacteria and the microflora that are in there that help the animal to digest the feed. So food or grass comes down the esophagus here, it goes into the rumen, it gets mixed around, the bacteria digest it, and then eventually it flows out through the omasum and the abomasum for further digestion in the intestines. But I'm really thinking about what's going on in the rumen at this point. So when we have our nice lush green 6 to 8 inch intensively grazed pasture, we have very happy rumen bugs. However, if we let the grass get too tall, we have what is probably better known as extensive grazing because it's not really being managed intensively. And we end up with sad rumen bugs because they can't do their job and they can't help our animals to produce a lot of milk. And the reason for this is that that young vegetative plant, when it's in that 6 to 8 inch forage height, has very, very thin cell walls. And those rumen bugs try to break through these cell walls. And this is kind of like us trying to break through drywall. It's very thin, it's very easy to break through, and it only makes up about 20% of the total plant. The cell contents is where all the really good stuff is. A lot of the protein, a lot of the sugars, a lot of other nutrients are found in the cell contents. So that young vegetative plant provides a lot of really good nutrition for the rumen bugs. So we've got those rumen bugs breaking through, making these cell contents available to other kinds and types of bacteria in the rumen. In our old over-mature plant, what ends up happening is the cell wall thickens up as that plant grows and goes into the reproductive stage of growth. It becomes upwards of 80% of the total cell. And so what we've done is we've taken something that is easy to break through like drywall, and we've turned it into a concrete block wall. It's very, very difficult for those rumen bugs to break through that cell wall. And then when and if they can, you end up with much less in the cell contents, and so not as many nutrients available for those rumen bugs to use to then help the cows to produce more milk. Now, the cell walls themselves are made up of 3 components: cellulose, hemicellulose, and lignin. The cellulose and the hemicellulose are very digestible by the rumen bacteria when it's in the young vegetative plant. Basically, cellulose is a chain of sugar molecules, and hemicellulose is a chain of sugar molecules, but it has short branches off of it as part of the way the fiber holds itself together. In the older over mature plant, we can have upwards of 50% lignin, and the lignin is totally indigestible. So you can see we've gone from a 10% lignin content up to about a 50% lignin content, which means we've gone from 90% digestible down to only 50% digestible by those rumen bugs. And again, those cell contents where the protein and the sugars and lots of other things are available, that has been reduced rather significantly as well. Now, the challenge with this is that our pasture plants are alive and actively growing. So they're going to change in yield and quality every single day and even over the course of a few hours. And so that's why we really talk about using that rotational stocking method, because then we will have plants that are in the right stage of growth all the time as their regrowth is staggered. As cows come out of a paddock and it starts to regrow, they go to the next paddock, they come out of that one starts to regrow. And so instead of going from short, not highly available type pasture to over mature, not very palatable pasture, we pretty much are trying to keep our paddocks all in that same stage of growth throughout the grazing season, from paddock to paddock. Now, where you really see this happen, go back here for a second. Okay, where you really see this happen is in the neutral detergent fiber. And if you've ever gotten a forage test, the NDF number is a reflection of how much cellulose, hemicellulose, and lignin is in the plant. So those three components that we just talked about. In that 6 to 8 inch plant, our NDF level can be as low as 33%, especially if we have a relatively high content of clover in the pasture. Once we let that pasture get up to 10 to 12 inches, then the NDF values will go up to 50 or even 55% of the plant parts that our cows will actually eat. In terms of intake, when we look at dry matter intake as a percent of body weight, if we weren't feeding anything else to our animals, this is kind of a theoretical example, at that 6 to 8 inches, we could achieve a dry matter intake of 3.6% of body weight as dry matter intake. Whereas at 10 to 12 inches, because of the fiber content, they would only be able to eat 2.4% of their body weight because it would just stay in the rumen longer, and they would not be encouraged to, or they wouldn't want to get up and graze more because the rumen would stay full longer. Now, if we look at the nutrient profile of a 9-inch tall orchardgrass plant, what we find is the top third of that plant is usually the highest in quality. You can see here in our example, it's 27% protein, it's about 38% NDF, and the energy content is 0.79. So very high quality feed at the top of the plant. The middle portion of the plant is 23% protein, 44% NDF, and a little bit less on energy. And then the bottom part of the plant, which is the stuff that we usually leave behind, is going to be much lower in protein, much higher in NDF, and also lower in energy in that bottom third of the plant. And what we find is that in research from all over the world, grazing animals tend to come through, and their first bite, they take the top third of the plant. Their second bite, they take the middle third of the plant, and then they leave the bottom third of the plant. So in this example, the cows would actually leave this bottom portion in the pasture, and their 2 bites that they take off each plant would have these relative quality values. Once you let your plants get that much taller, this bottom third, if it ends up being 4 or 5 inches, will be much higher in NDF, as will the middle third and the top third, because you end up starting to get more and more of those fiber components in the top part of the plant. So just some quick calculations to show you what a difference this makes in their intake is if we assume that the pasture is either 33% NDF or 50% NDF, and we want to have a diet that's 70% forage, we're going to use a cow that weighs about 1,100 pounds. And we're going to do a little math here. I know most people don't like to think through math problems, especially mid-afternoon when you're ready for a nap, but we will just go through this very quick. So an 1,100-pound cow, and we want her to eat a total of 3.5% of her body weight, needs about 38.5 pounds total dry matter intake for the day. So if we want a 70% forage diet, that means we need to get 27 pounds of forage dry matter intake into her. And that 27 pounds divided by 1,100 pounds of her body weight gives you the result of she'll eat about 2.4% forage as a percentage of her body weight. Or you can also do it on the NDF basis. I just picked 1.1% of body weight from NDF. You could go a little higher than that. But in this example, we end up with 12 pounds of NDF as a percent of her body weight coming in from the pasture. So that's what we're trying to achieve right there is 2.4% forage in the diet as a percent of her body weight. So looking at which pasture can they eat more of, that 50% pasture, which is the more mature, If it's 27 pounds that we're trying to get her to eat, that gives us 13.5 pounds of NDF. That's higher than our estimate that she can eat 12.1 pounds of NDF total, and that ends up being 1.2% of her body weight. If we look at the 33% NDF pasture, that's 8.91 pounds of NDF, which is less than what we predict that she can eat, which means the bottom line here, I'll skip the next couple of calculations, is that she's more likely to eat that 33% NDF pasture, and she's likely to eat a whole lot more of it because she can eat up to 12 pounds. And again, the higher the intake, the higher your milk production and the lower your costs. So chances are she's going to eat more like 36.7 pounds of that 33% NDF pasture. Now, another factor that comes into play is that our cows are selective grazers, and they use their nose and they use all these whiskers on their nose to help them determine what it is that they're going to eat while they're out there. They also use their sense of smell so that they can avoid places where there's manure or where urine has been left on the pasture. Excuse me, I'm just taking a sip of water here. So because she's a selective grazer, one of the things that she will also avoid is this thing that I call the ouch factor. And that is when she sticks her nose into a pasture and she feels all kinds of sharp, hardened off plants. This notebook here is 8.5 by 11. And so you can see that the pasture, this has been grazed, and they barely grazed it down to maybe a third of that 11-inch tall notebook. So they basically just came through and took off the top part of the plant because down below that, that ouch factor of too much fiber, too much stemminess, too much stalkiness prevented them from eating it any closer. Really, you want it to be nice and lush and soft when they stick their nose in down here at the bottom of the plant profile. So that's another factor to consider, is how the animal is going to behave in terms of what she selects to eat while she's out there. Now, in terms of balancing the ration does have an impact on pasture dry matter intake, and I'm going to approach this a little bit backwards. Again, I'm going to go through some really quick calculations here. But if we use that NDF as a percent of body weight, as a predictor of how much pasture they can eat, and we want them to eat a total forage dry matter intake of about 2.2% of their body weight, we can get 30 pounds of forage dry matter intake on Holsteins and 22 pounds on our Jerseys and crossbreds probably as well. Now, if we're going to feed any dry matter from stored forages, such as some dry hay or some baleage, you would subtract that off what we're predicting our pasture dry matter intake would be. And obviously, I'm a fan of more pasture is better. From there, we're going to quickly go and look at some protein and energy relationships that also have an effect on intake from pasture. So most of our pastures have protein levels that are much higher than what our animals actually need and that are more than our rumen bacteria or our rumen bugs need. A lot of cases, our pastures are between 20 and 30% protein, whereas our animals really only need 16 to 17%. The protein in pasture is highly rumen degradable, which means that it can be broken down in the rumen into amino acids, peptides, and ammonia. We really don't want ammonia in the rumen because it can cause some problems. When you have excess degradable protein, you end up wasting energy in the animal. That degradable protein, once the rumen bugs break through those plant cell walls and get to the protein, they can either be used, and if they are used, what those microbes are doing is they're taking that protein, they're matching it up with carbohydrates, and then in a second here we'll have something pop up that says more microbial protein. And that microbial protein passes to the lower part of the digestive system, and the cows can use it for milk production. If the degradable protein is not used over here, those rumen bugs convert it into ammonia. The ammonia has to get into their bloodstream, and they use energy to move that ammonia through the rumen wall, through the cells. It goes into the blood. In the blood, it goes to the liver, where the liver converts it to urea, and you end up using energy in that process, and then you have urea being excreted out the back end of the cow. So you're using energy over here that could otherwise be used for milk production. The other thing that happens is, if you think about what's happening in the rumen, our cows come in the barn, they eat grain, or maybe they eat a little bit of silage. They go out on pasture and they graze. They rest, they chew their cud, then they get up and they graze again. Well, what's going on in the rumen here is that our carbohydrates, non-fiber carbohydrates, come in from our grain, and then they go out and they graze, so they get some protein. And when that happens, we end up with microbial protein. Later out here in the day, we've got some carbohydrates and some protein that are probably, the carbohydrates are probably still in the rumen from when they were in the barn, and we get the protein, and we again get microbial protein. The problem comes later on in the day when they get up and they graze again. They've probably used all of those carbohydrates, and so all they're getting is protein, and what you end up with is not necessarily more microbial protein. We may end up with ammonia. And there are two factors with ammonia. Number one is the energy, but then the other factor is that our animals actually have post-ingestive feedback where they can detect that they've had too much protein, especially if we're feeding protein in the barn. It will change what they prefer to eat when they go out on the pasture. So if you feed too much protein in the barn and they go out to pasture, they're not going to maximize their dry matter intake because they've already met their protein requirements. Similarly, later in the day, when they get up to graze, once they've had enough protein and it's being broken down into ammonia, that can be cause a feedback mechanism where it causes them to stop grazing prematurely because they don't have the carbohydrates available in the rumen to utilize that protein, and so it causes them to stop grazing a little bit earlier. This goes back to the previous discussion about those three factors that influence dry matter intake. So this will affect the amount of time that they spend grazing. Just quickly, we had not a little research project. It was a pretty major research project here in New York where we tested out this theory. This was actually from Darrell Emick's PhD project, but he planted a pasture where it was a strip of clover, a strip of grass and clover, and then a strip of grass. And the cows could come in and choose any one of those three areas to graze in. The crude protein content of those strips were 32, 28, and 24%. So the clover was the highest, the mixture was in the middle, and then the grass was the lowest protein. And I'm just going to quickly show you some pictures. This is the all clover strip. This is the grass with clover strip. Then the next slide shows the grass with clover, and then the all grass. So it was seeded down in these three big long strips. And what he did was he fed those animals two different grain mixes, one that was 11% protein and one that was 21% protein, and they were equal on their energy content so that energy wouldn't influence their grazing behavior. And what he found was that when he fed the 11% protein mix, this is the amount of clover they ate, this is the amount of the mixture that they ate, and this is the amount of grass that they ate. When he switched them to the 21% protein mix, their intake of grass went up, and their intake of the other two mixtures or plant choices went down. And then when he went back to the 11% protein mix, their intake went back to the original, pretty much the original levels where they ate less grass, more of the mixture, and more of the clover in the pasture. Milk production, when he went to the 21%, dropped. And that is likely a combination of the cows not eating as much pasture out there, although intake was not being measured in this study. And it's also probably due to the fact that the cows then had to use energy to get rid of the ammonia that was in the rumen by converting it into urea. So kind of some neat research that was done here that really shows that what you feed in the barn will influence their intake while they're out on pasture. I used to always tell people that you should feed a little bypass or a little undegradable protein just in case, and I have since determined that I'm not recommending that anymore because of the fact that we do see these changes in intake. What this says down here below is energy is the first limiting factor, and that's really what you want to be focused on in terms of supplementing. So your non-fiber carbohydrates, your NFCs, these are your sugars and starches like corn, barley. There are some organic producers that feed molasses. It is a little bit less expensive because you feed less than you do of grain, but it may also limit some milk production and body condition in some of the herds that I've seen that have tried it. The other thing is there's some folks out there trying the no grain concept with just pasture. Generally speaking, 55 pounds of milk is about where people end up topping out on their production. There can be challenges with body condition and reproduction, especially if your genetics, if you've been selecting for cows that have high milk production, because they may have a bigger body type. They may be somewhat dependent on the grain, so you have to take a look at that. And of course, there's also a limit on how much pasture they can eat without any grain, just because of the fact that they don't have enough energy to deal with that protein. Again, some folks are feeding molasses. They get these big tubs, pour it into a bucket, scoop it out, and put it in front of the cows in the barn. Most people are feeding it at 1/3 the substitution rate to cornmeal. So if you feed 9 pounds of cornmeal, you'd only feed 3 pounds of molasses, just as a simple example. I did do a little research project for 2 summers on a farm that's feeding molasses because I was trying to figure out why it only works for some farms and doesn't work for every farm. Rather than getting into all of the data, I'll just quickly show you that this is the percent protein in the pasture in the bars. So it was pretty consistently up over 20% protein. Protein's over here on the left axis. And then these points along here are the milk urea nitrogen, which is an indicator of how much of that protein is turning into ammonia and then urea. And you can see that most of the time it was hovering between 15 and 20, which is on the high side of what we recommend. So definitely molasses is an option. I just don't know that it provides enough energy for the rumen bugs to utilize the protein that's in the pasture. And so, this may be going on as well. There may be some intake limitations as a result of too much protein. So when we're looking at our carbohydrate sources, we want to have a combination of carbohydrates that digest differently in the rumen. So we've got molasses up here at the top, ground oats and barley, and then we slowly go to drier feeds or bigger particle size feeds. I've got molasses here in the middle because I'm still wondering if it stays in the rumen longer than we think it does. But the bottom line is that processing in moisture will make a difference. The reason you want to have a variety of things, if possible, is to stretch out your carbohydrate sources over the entire time that your cows are grazing so that they can utilize the protein that's in the pasture later on in the day. So I know I went a little quick there towards the end, but we really want to be managing our pastures for that high pasture intake. If you can get higher than that 30% minimum that they're looking for to meet the new standard, that's better than cutting it really close from both an economic standpoint as well as making sure that you're meeting the standard. I highly recommend that if you're looking at supplementation, that it's an energy supplement. It's not a protein supplement because your cows really don't need that protein, especially if they're getting that high pasture intake. And then, of course, we all know that now we have to document and document and document what you're feeding, how much you're feeding, and probably also how you're managing your pastures. So with that, that is the end.
Thank you very much, Karen. That was a lot of digestible information. It's great. Before we move to our question and answer period, we would like to ask you, our audience, to complete a very quick poll. So we have 4 questions for you to respond to, and each question will appear on your screen for about 20 seconds, and the first one is up. So if you could respond to that question, which is, as a result of this webinar, do you understand how to better maximize dry matter intake from pasture? So if you could just select one of those responses, you can just blink right on your screen. That would be great. And we'll just quickly move through these so that we'll have enough time for question and answer. Oops, are we, do we close that last poll? There we go. So our second question, do you better understand the interrelationships between pasture management, feeding, and animal behavior? Select away, please. Great. So I think we're just about ready to go to our next one. Looks like it just takes a little bit of time for the webinar to do this. Okay, so number 3, did you learn anything new about cow nutrition and rations? Select away. And just finishing up that one. Great, and I think we're just about ready for our last poll question. We really appreciate your time with us. Okay, number 4, will you make changes to the way you pasture your livestock or how you advise farmers based on what you learned today? You could just respond to that question, and then we will close our poll and get ready for our Q&A. All righty. Great. All right, so we are moving on to our time for questions. For those of you who may have missed the beginning of the presentation, to ask a question, you just use the question box, which is located right on the right-hand side of your screen. Just type in your question and hit return. You may or may not have your question box closed. If it is closed, you can click on the small plus sign next to the word question to open it up. And how this will work is I will be reading the questions out loud to Karen, and she will answer as many as we have time for. Alrighty, and if after the webinar, if you have additional questions that we don't get to, you can also use the online Ask an Expert system at eextension.org/ask. Okay, so Karen, I have a few questions that have been waiting in the queue, as they say. The first one, you showed a really beautiful picture of pasture, a nice pasture mix of grasses and legumes and dandelions. And this question says, do dandelions offer much nutrition?
Oh, yes. Dandelions are very high-quality feed. Years ago, when I was doing my work at Penn State, I actually sampled some dandelions just to find out what the quality was, and they were close to 30% protein and very high in energy as well. That's one of the reasons why in the spring you will see the cows almost preferentially grazing the dandelions, is because they are very nutritious. I would also suspect that there are some secondary plant compounds in dandelions that have some kind of a health benefit or nutritional benefit to our cows that we wouldn't normally find in a forage analysis. So if you've got lots of dandelions in your pastures, don't think it's a bad thing. It's definitely a good thing.
Great, thank you. So this question it says, recognizing that this presentation and discussion is primarily for dairy cattle, are the concepts, the general concepts, the same for beef cattle and sheep?
Yes, they are. If you're trying to grass finish beef or you're trying to grass finish lamb, you want to have very high quality pasture. You want to try to maximize their intake. One of the things about those kinds and classes of animals is that they do have a lower metabolic rate than a dairy cow does. So maximizing their intake is actually more like 2.5% or 2% of their body weight from pasture. And so I know that next week there's a webinar on planning a pasture system. And you would plan based upon a lower level of intake, but you would still want to manage the pastures to maximize their intake using all those concepts that I talked about. They also are affected by those high levels of protein, and generally speaking, with grass finishing, we're not feeding any grain, and that's one of the reasons why it takes a little longer to finish an animal on grass, is that they are using energy to get rid of protein while they are also using energy to grow. So because they're diverting some of that energy, it just takes a little bit longer for them to finish. Instead of finishing it, 12 or 15 or 18 months, sometimes it takes until they're 18 or 20 or 24 months to really get the kind of finish that you're looking for. I think that answered the question. I hope.
Great. This question says, as a 100% grass-fed livestock farmer, I need a non-grain energy supplement along with baleage for winter feeding. Can you recommend a non-grain energy supplement?
That is challenging because there aren't a lot of non-grain supplements. Molasses would be a non-grain supplement. Beet pulp or citrus pulp both have fairly high energy contents. They also provide some fiber to the animal. So I think that those would meet the definition of no grain. And then I know some people that have put up like small grain silages before the grain is formed in the plant, and those tend to be also somewhat high in energy.
Great. This looks like a comment here. It says, don't forget to manage for pasture longevity, diversity, etc., not just for cow nutrition. Consistently grazing at 6 to 8 inches may cause pastures to decline quicker than grazing taller. There needs to be a balance between the two, or else you will be replanting pastures routinely. Do you have a comment on that?
Yeah. In my experience, I haven't found that to be true. I've worked with a lot of dairy farmers that are grazing at 6 to 8 inches, and they've never had to reseed a pasture. If anything, their pastures have continued to get better, and much of that is because there is organic matter being returned to the soil through manure, as well as through the roots dying back after each grazing. Of course, there's always stuff that they won't eat, so we end up having to clip our pastures. And by grazing it at that shorter height, what I found is that those pastures thicken up a little bit better because the sunlight can get through the canopy and can get down to those basal tillers at the bottom of the plant that allows that plant to put out more tillers and become a thicker, denser sward. So I know the argument on the other side of it. I'm just saying that I haven't seen that in practice on some of these herds that I've been working with for 15 or 20 years that, have been managing their pastures this way over a very long time. So I'm not saying it's wrong. I'm just saying that's not my observation.
And maybe you touched on this. I thought there was going to be some information on number of tillers per plant. This person was curious on your comments about tillers per plant.
Yes, I meant to cover that back in the part where I was talking about pasture yield as a function of height plus density. And the way you get that dense pasture is by encouraging the plants to put out more tillers by grazing it fairly often and allowing the sunlight to get down to those basal tillers. And the more tillers they put out, again, the denser your pasture ends up being. And one last thing on that, too, is that the more tillers you have per plant, the greater your intake per bite will be, because when your animals wrap their tongue around that grass, they get more leaf material and less air. So that also helps to maximize intake per bite.
Great. Looks like there's a few questions on mob grazing. One says, how does mob grazing figure into this? We move herd regardless of grass height / age. And then, oh, go ahead.
No, you can finish.
I'm sorry, I'm missing that last. Oh, and then looking at your plant height calculations versus plant components, would not mob grazing be limiting?
Okay.
So two different questions, but both regarding mob grazing.
Right. If you're doing the rotational stocking method with dairy animals and you're concentrating them into a small paddock twice a day, and you're moving the fence twice a day to give them another small section, which is really what we recommend you do, you're actually doing mob grazing. It's just you're mob grazing on a shorter height than what you would do with beef cattle. I don't think we think of that management system as being mob grazing, because most of the articles that have been written about mob grazing are really related to beef cattle and folks that are doing it in other parts of the country where they are, they have different species of grass than what I'm accustomed to working with. So when dairy farmers ask me about it, I say, well, really we are doing mob grazing. We just don't think of it as being mob grazing because we think of it more as being rotational than mob. And if you were to calculate your pounds of live weight per acre with each of your moves, I think you would find that you're very close to what they're using in the beef industry for mob grazing. And did I miss part of the questions?
I think, well, I'm sure people will chime in if you did. Okay. I'm just going back to the non-grain energy supplementation. A few folks kind of chimed in. Someone had said, how about cottonseed oil as a non-grain energy source? And then another person suggested that they have a client using soybean whole pellets without any grain. Does this substitute for an energy source well enough?
See, because I'm in the Northeast, we don't have cottonseed oil. We have cottonseed, we have whole cottonseed, and sometimes we have cottonseed meal available to us. So I don't think about cottonseed oil necessarily, but it depends. I think I would say yes, that those products would have enough energy and they're not really considered to be a grain necessarily. The soy hulls, they are from the outer part of the soybean, and so anybody that's really being a purist about no grain might consider soy hulls to still be a grain product, but they're a really good fiber source, and they do have some energy, so they, in my mind, I think that they would be an option unless you want to relate the soy hull to the soybean and, discount it because it does come from a grain crop.
Okay, someone just chimed in. How about dry sugar beet pellets?
Yes. Yep. that would too, because again, I had mentioned beet pulp. Similar product. It comes from the sugar beet, and it's not necessarily, it's not a grain. So that would be a good source of energy as well.
Okay, I'm going to move on to a totally different question. Do you have the intake requirements for dairy goats? And could you comment on rotational grazing using a combination of cows, sheep, goats, etc.?
Okay, that's a really big question.
Mm-hmm.
Intake for goats is probably going to be in the 2 to 2.5% of body weight range. Generally speaking, the other part of the question was about grazing them with sheep and
multi-species grazing.
Multi-species grazing. Yeah, the way you would figure that is you would take the number of each kind of animal that you have and figure out on a percent of body weight what their intake would be. So you might be looking at 2% for the goats, 2.5% for sheep, 2.5 or 3% for beef animals, and then if you had a few dairy cows in there, you could use 3.5%. Calculate the number of animals times their body weight, take their body weight times their intake level, and then calculate how much all of those animals together would need to eat in a day, and then determine whether or not 1 acre of pasture can meet their intake requirements for that one day.
Okay, hopefully that answers her question here. Okay, so I have another sort of comment question. At 6 to 8 inches, manure may be very loose because of high digestibility, and pasture nutrition may move through the cow too quickly to be fully utilized. So should we be feeding some fiber to slow passage or graze somewhat taller?
I get this question all the time, and I really don't have an issue with the manure being loose. They do get a tremendous amount of nutrition out of it, even though it does go through them quickly. What ends up happening is they end up with a higher intake level. And if they have a higher intake level, they're going to produce more. So there is a benefit to it being that digestible. If you were going to feed something to, quote unquote, slow down the rumen, you would have to feed a lot in order to have an impact on it, because there are bacteria in the rumen that are going to digest the pasture, and that's all they're going to work on. And then there's other kinds of bacteria that will digest, the hay or the baleage that you're feeding. And it takes a lot you end up diluting the pasture bacteria by feeding enough to have an impact on the pasture. I don't know that I'm explaining this correctly, but for example, if you needed your animals to eat 20 pounds of pasture and you wanted to slow that down, you would have to cut it to 10 pounds of pasture and 10 pounds of hay to really have an effect on the digestibility rate of the pasture. It would stiffen up your manure, but it would also decrease animal performance. So it's sort of like you have to decide what you're willing to give up and how much you're willing to give up in production just to see the manure stiffen up a little bit. And is it really worth trying to stiffen up the manure if the animals are doing fine without their manure being stiffened.
Okay, and this one's related. What about loose manure later in the grazing season with weaned calves on pasture?
I'm wondering if it's weaned dairy calves or beef calves.
Let's assume dairy.
Okay. If it's dairy and they have loose manure, I would run fecal samples to make sure that it's not a parasite problem. If it's not a parasite problem and their manure is loose, or it's not E. coli or some other bug, if it's just loose and they're healthy and they look good, I'm not really worried about that. And same thing in the situation with beef. Usually, beef calves are on mom for a longer period of time, and so they're accustomed to grazing and getting some milk. And then once they're weaned, if they have really loose manure and you're concerned, I would run some fecal samples just to be sure that it's not a parasite problem.
That's a great segue, because the next question I had here was, aren't parasites an issue, especially in organic? I don't know if you have anything else to add to what you just said.
The whole idea of pasture diversity and having lots of different kinds of plants out there is a great one to deal with parasites, because there are plants that have condensed tannins like bird's foot trefoil, and there's 3 or 4 others that if your animals eat those, can help to protect them against the parasite load. And then, of course, there's other supplements that you can feed that will help to boost the immune system, like kelp, that will also help to protect them against getting a parasite infection if there ends up being a big parasite load coming in from the pasture.
Okay. When the grazing season ends, what feed is best to ensure steady milk production? And I know you've written some on transition on and off pasture.
Mm-hmm.
So do you want to?
Yeah, I would start, because pasture is very similar to haylage or baleage. That's the feed that I would start to introduce as you're going into the fall and as your pasture growth rates are starting to decline. You need to transition them onto stored feed for the winter. And if you increase the amount of haylage or baleage that you're feeding just a little bit as you notice your pasture slowing down, that will make the easiest transition. If you're feeding corn silage through the summer, or if you're planning on feeding it in the winter, I would introduce that after you get to the point where you're feeding the amount of baleage or haylage that is pretty close to what your winter ration is going to be. And then I would start either increasing the corn silage or introduce it once you've transitioned onto more of a grass-based or alfalfa-based forage.
Okay, so we're pretty much running out of time, but let's see. Could you talk about pasture and heat stress?
Pasture and heat stress?
Mm-hmm.
When it's really hot, and I'm talking mid-80s and above, and it's very humid, when you have that combination of high heat and humidity, you definitely, especially with dairy cows, want to put them into a pasture that has some shade, or put them in a barn where they can cool off under some fans during the hottest part of the day. I would maximize their time out on pasture during the cooler evening hours. So once the sun starts to go down, if they can get out there, and if they can stay out there a little bit later into the next morning to help their bodies to adjust for the heat, that's a really good strategy. I know some farms that I've worked with have gone to changing their milking times so that the cows are in the barn being milked during the hottest part of the day, and then they get turned out again early evening and then they're back out in the morning when it's still nice and cool. So, you know, they're milking at like noon or 1 o'clock, and of course noon or 1 o'clock, or midnight or 1 o'clock in the morning, as a way of trying to optimize the amount of pasture their cows are eating and keeping them comfortable during hot weather like that. If you have shade in your pastures on a regular basis and your temperatures are, you know, in the 60s and low 70s and it's not very humid, your cows will stand in the shade even if they don't need it. And so we do have a tendency to tell people, you know, you don't need to have shade in all of your pastures, because if they're standing in the shade when they don't need it, it means they're not grazing and they're not maximizing their intake. So having some pastures with shade for those days when you need some shade is good, but it doesn't have to be in every single pasture on your farm.
And that's actually a good segue into talking about our next webinar that's coming up. We will, on October 1st, Sarah Flack, who's a national pasture management specialist, will be joined by Cindy Daly of California State University at Chico, and they'll be talking about setting up a grazing system. So shade will definitely come up in those conversations or that presentation. And I know we do have to end the webinar, but I know that there were some questions about the rule in particular. I would encourage you all to go back to the archives of some of our past webinars where we talked more specifically about the rule and calculating dry matter intake. So those, along with the articles and videos that we have published thus far, are on the website that you're seeing on your screen right now, which is the extension .org/organic_production. And lastly, a quick reminder to look for an email request to complete an online survey regarding today's webinar. I want to thank you, Karen, so much for joining us today, and thanks everyone for coming. Have a good day.